Um, we shall now begin with the meeting. Good morning, good afternoon, and good evening to everyone joining us from different parts of the world. A very warm welcome to the day two of the Networking International Conference on Emerging Trends in Expert Systems, Applications and Security, Asia Chapter 2025, or as we fondly call it, TEAS Asia 2025. I am Nalhangma Subba, and it's an absolute pleasure to moderate today's online session. This international conference is jointly organized by the Banking Academy of Vietnam, Hanoi, Vietnam, and Apex University, Jaipur, India, supported by Shree KKarni University College, Jaipur, and managed by KK Consultancy Services, India. This year, we received an overwhelming response with over 400 paper submissions from all across the globe. After filtering out AI-generated and plagiarized content and a rigorous peer review process by our expert panel, only the top 80 papers were selected for the presentation. Based on the performance and the recommendation of our session chairs, these selected papers will be published by the Springer Nature. Yesterday, on 29th of October, the day one of the conference, we had an incredible series of keynotes, paper presentations, award ceremony, and discussions that truly embodied the spirit of innovation and inclusivity that was offline in Vietnam. As we step in day two, we carry forward the same enthusiasm, ready to dive deeper into thought-provoking sessions and interactive presentations that will continue to shape the future of intelligent systems and digital security. With that, I'm pleased to introduce our session chair for this segment, Professor Amit Sharma, sir. We welcome you, sir, for the moderating session. And after that, before we proceed further, I would like to share a few important instructions for all the paper presenters to ensure a smooth and timely session. Number one, each presenter has 7 to 8 minutes. Please stay within the time limit. Number two, a short reminder will be given to you 6 minutes to your presentation. Number three, briefly cover your research context, objectives, methodology, key findings, and conclusion. A short Q&A may follow after your talk of 1 to 2 minutes. Keep your responses very brief and focused. Keep your mic muted when not speaking and stay for the full session to support the fellow presenters. With the kind permission of a session chair, we shall now proceed with the paper presentation. Okay, I would like to invite our first presenter of the day, presenting the paper titled Decentralized Ledger Systems for Data Integrity, a Comparative Study with Feedback Mechanism, under the quote number 185. I request Ma'am Alpna Bansal to kindly take the virtual stage and begin the presentation. Over to you, ma'am.
Thank you. Hello, everyone. My name is Alpna Bansal. I'll go ahead and share my screen and present my work. I hope you're able to see my screen.
Yes, ma'am.
Yeah.
Thank you. So today I'm presenting my work on decentralized ledger systems for data integrity. It's a comparative study between traditional databases and decentralized ledger systems. This is the outline of my presentation today. I'll be covering the following key topics during the presentation today. Coming to the introduction, as we all know, the traditional centralized databases are based on the conventional databases and hierarchical models, and these are vulnerable to a wide range of threats. While decentralized ledger technologies, or in short, we call these as DLTs, like blockchain, promise tamper-evident, consensus-driven data integrity without the need for a trusted central authority as opposed to traditional database systems. In my paper, I'm presenting a comparative analysis of DLTs against traditional database architectures while simultaneously focusing on inherent security mechanisms, performance characteristics. Until date, most of the studies have evaluated DLTs against the cryptographic or economic perspective. But in this study, I'm focused on system level feedback and control. With this paper, I'm trying to bridge the gap between security protocol designs and system engineering, meaning which it will help organizations and individuals to decide on between DLTs and traditional database systems. It's offering a multidimensional evaluation of decentralized ledgers for data integrity assurance. Now, here I'm presenting a comparison between blockchain versus traditional databases. In terms of architecture, traditional databases operate under a single node and a very tightly controlled cluster, while DLTs uses a decentralized architecture where data records are appended to each other through a consensus mechanism. In this case, a proposed state is checked against protocol rules and cryptographic signatures. And also, DLTs use protocols like proof of work, proof of stake. In terms of resilience and recovery, although both the technologies or both the types of systems have their own drawbacks, but in traditional systems, recovery is mainly dependent on administrator intervention and log-based restore because in case of traditional systems, it's more at, the administration is required. There is a central authority which kind of controls everything. While in case of blockchain, recovery is systemic, nodes resynchronize from peers, and there is a validated block history. But as I mentioned, that the both of the systems have their own drawbacks. But in case of traditional systems, if a log is compromised, as it's a log-based restore, recovery can be incomplete. While in DLTs, reorganizations due to forks or delayed consensus can temporarily destabilize the data views, but recovery and resilience is more in case of DLTs. Now, if we look at the scalability and latency, hereby I've provided a diagram also, which provides a comparison between architecture and feedback of traditional databases versus DLTs. On the right-hand side is the DLTs, and on the left, I'm showing traditional databases. Now, coming to scalability and latency, centralized databases are optimized for the throughput and latency. I've provided my work and the parameters and the facts and figures in the upcoming slides. So centralized databases are optimized for the throughput and query latency, while blockchains, on the other hand, you'll see some kind of latency sacrifice in order to gain auditability and consensus. Although there are some recent innovations which kind of aim to improve both consistency and speed uh, while in the arena of decentralized settings. Now, if I go ahead and touch and see interoperability and governance between the two systems, in case of traditional databases, the governance lies typically within very confined boundaries and provided administrative domain and is governed by an organizational policies wherein it is deployed. While in blockchain systems, in contrast to traditional systems, it requires protocol level governance. And this mechanism particularly introduce additional feedback channels and require practical participant coordination, especially in case of permission blockchains. Now, coming to feedback comparison, traditional systems implement reactive feedback, while DLTs offer proactive feedback, which is anyway better than reactive feedback. In this case, validation and accountability are embedded in the write process itself, like while the logs are being written. Now, the way I have conducted this research, experimental design, and how I've implemented is I tried to design a series of controlled experiments in order to assess the performance of the DLTs versus traditional database systems under stress and failure conditions. I tested each system under the different kind of stress conditions like normal load, burst load, and node failure. The platforms for both the technologies or systems were chosen based on maturity, the kind of documentation support available, and the widespread use in industry and research. And I tried using two representatives from each type of systems or architectural categories. For decentralized ledger systems, I tried using Ethereum public blockchain and Hyperledger Fabric, which is an open source permission blockchain. And for traditional databases, PostgreSQL and MongoDB NoSQL. And in this case, each experiment which I tried was conducted for approximately 30 minutes, and I tried repeating it 10 times to ensure that the statistics which are being collected are significant. Coming to the evaluation matrix, I've captured four matrices here, which mainly performance, throughput, and latency, recovery and rollback behavior, and auditability analysis. So here I'm presenting the comparative evaluation based on the metrics I've recorded in terms of performance, security, and scalability. And this particular slide presents the empirical results of the experiments I had conducted in order to support this research. And it compares all the three aspects here. Now, I have provided a table with my key findings and statistics and this diagram also. So this diagram charts out
Ma'am,
the,
pardon me for
sorry,
interrupting you, ma'am, but you have 1 minute to complete the presentation, ma'am.
sure, thank you. So this provides a throughput comparison of blockchain versus database systems. We can see that the throughput is less in blockchains versus database systems. And even though the throughput and latency is not as great in case of blockchain and distributed ledger systems, but auditability and recovery is great in distributed ledger systems. Now, as I conclude my presentation, I would like to say that integrity should not be treated as only a cryptographic property. Rather, we should view it as an emergent system behavior. And the choice between blockchain and database systems shouldn't be just assume decision makers of an organization should base their selection on contextual need rather than just assume that only one particular solution would be a fit. I would also like to present the future research work which can be done in this area. Future work could expand into an experimental environment. The actual real data sets are used, and also exploring the application of zero knowledge proofs and verifiable computation in traditional databases that actually kind of will allow decision makers to approximate blockchain level of assurity, but without incurring the overhead that blockchain consensus mechanisms imply. Thank you.
Thank you so much, ma'am, for your insightful presentation and well articulated presentation. Thank you so much for that, ma'am. Now we are open to questions, if any.
Um,
Hello.
Hi, Alpana. I have one
Yeah,
question here.
yeah,
Yeah,
sure.
thanks for the presentation. So typically a database satisfies the ACID properties, right? I think you
Yes.
touched upon some of them,
Mhm.
atomicity, consistency, isolation, and durability. So which all properties this decentralized database lacks, if you have to touch base? And maybe can you talk about the what kind of workload it's best suitable for?
Sorry, what kind of workload is best suitable for? I did not get your question clearly.
Yeah, so like definitely the banking application, they require
Yeah.
like very high consistency. So what kind of workload it can be used? And also the first part of question was where in ACID
Yeah.
properties, where does it lack?
Okay. So I would touch upon the latter part first. What kind of workload DLTs would imply or would benefit more? Based on the work I've done so far or the research I've done so far, I would say DLTs would prove very beneficial in case of financial transactions. And I mean, that kind of everyone is widespread and everyone knows. But I have done some of the research which I have not necessarily presented in this presentation is DLTs would greatly benefit a workload in case of healthcare and pharmaceuticals. And coming to the first part of question that in case of asset properties, what properties DLTs necessarily lack? So I would first like to mention that DLTs is distributed ledger technologies are based on cryptographic security, decentralization and consensus mechanisms. And according to me, I would say that isolation is a property which you can say that may lack in case of DLTs because if it is a public blockchain that all the participants in the network would be able to see what's being transferred.
Thank you.
Okay, Alpana, one question from my side.
Yeah, sure.
Which specific DLT architecture solve the most significant performance degradation when implement your feedback mechanism and why?
So according to me, I would say it's proof of work concept, but proof of work concept that kind of benefits more. But the only drawback I see there is that it requires more energy. So computational overhead is more, but according to me, POW or proof of work would be the best one. And also
All
permission
right.
blockchains.
Okay, thank you.
Thank you so much, ma'am. Now, I would like to invite our second presenter of the day, presenting the paper titled Anomaly Detection in Backup Data on Cloud under the code 186. I would request Sir Vishal Sanghani to kindly take up the virtual stage and begin the presentation. Over to you, sir.
Yep, sure. It's actually sharing this problem. Sorry, guys, I'm having a little difficulty in sharing my presentation.
All right, sir. Sir, not an issue. Would you like giving the presentation at the end, sir, if you don't mind?
Yeah,
Meanwhile,
that should also be fine. Yeah, I mean, that should be fine. Yeah.
right, sir. All right. Thank you so much.
Yep.
Meanwhile, we'll be moving to the next presenter, the third presenter of the day. Um, the third presenter of the day, presenting on the paper titled Leveraging Artificial Intelligence and Machine Learning in Modern Agriculture Applications and Impact under the code number 203. I request Ma'am Anuradha Bridgewell to kindly take the virtual stage and begin the presentation.
Thank you. I'm sharing my slide.
Sure, ma'am.
Am I audible?
Yes, ma'am, you're audible.
My screen is visible?
Yes, ma'am.
Okay. Good afternoon, everyone. I am Anuradha Vijwal from Kanya Gurukul Campus, Dehradun, Haridwar. Today, I will be presented our work titled Leverages Artificial Intelligence and Machine Learning in Modern Agriculture Application and Impact. Paper ID is 203. The world is facing serious challenges. Just wait. I can't move my slides. Just okay.
Ma'am, you may refresh your page. I think it's something technical issue.
Yes, ma'am.
Ma'am, refresh your page. I think it's some technical issue. So you
Oh,
can try
okay,
again.
ma'am.
Yes.
Okay, ma'am. I can't move my slide, ma'am.
Uh, would you like some
You
time,
can.
ma'am, for this? Or
Just wait a few minutes, ma'am, please.
sure, ma'am.
Now my screen is visible.
Yes, ma'am, it's visible.
Okay. Now slide are also moved.
Yes, 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 ma'am.
Okay. Thank you. First, this is the content of my research work. First is abstract, introduction, research objective, literature review, methodology overview, result summary, future direction, challenges, limitation, conclusion, and references. First is abstract. The world is facing a serious challenges how to grow more food and fewer resources. Traditional farming techniques are no longer enough. Our research focus on how AI and ML can make farming smarter, from predictive crop yield to detecting disease and optimizing resource use. In this study, we explored how AI/ML can directly improve farming outcomes. We targeted three main applications. First is crop yield prediction, second is crop disease detection, and third is precision farming using IoT. The results were exciting. Our CNN model achieved 95% accuracy in detecting plant disease. Random forest and XGBoost gave R square above 0.88 for yield forecasting. And when we combined IoT and ML, we observed 20 to 30% saving in water and fertilizer. So overall, AI and ML are not just futuristic idea; they are real solution making agriculture more productive and sustainable. Now, modern agriculture is under constant pressure due to climate change, rising food demand, and resource scarcity are major global issues. Traditional methods rely heavily on experience and manual observation, which can be slow and inaccurate. AI ML bring intelligence and precision into this process. They help farmer make data-driven decision, whether it's about the best time to show how much water to use or detecting disease early. When we connect these systems with IoT sensor that collect the real data like temperature, moisture, soil nutrient, etc., the farming becomes starter, faster, and far more sustainability. These are my research objective. The research objective, our study we relied with three clear goals. First is First, to analyze how AI/ML are transforming current agriculture practices. Second is what? To implement and test AI-based system to predict crop yield, detecting disease through image recognition, and managing precision farming using IoT. And third, to evaluate how well these models perform using matrices like accuracy, F1 score, R square, MAE, and resource efficiency. The ultimate aim was simple: find out whether intelligent system can truly enhance productivity while serving vital resources. Now, this is my literature review. We received several research papers work to understand where AI currently stand in agriculture. For example, shows random forest. My first paper is shows random forest model predict yield better than traditional regression. Second paper is shows use CNN to detect plant disease with over 95% accuracy on the plant village data set. Third is what found the IoT ML system reduced water and fertilizer use by around 30%. But there is a catch: this system often fail when applied to different region or climate. Data scarcity and lack of localized data set remain big barrier. So our study focused on this gap by creating adaptable, scalable AI models suitable to derive agriculture environment. These are the methodology we are used. Here, how we approached it. First, we combined AI model, machine learning algorithm, and IoT data into one workflow. The data come from the three major sources. First is plant village data set for plant disease image. Second is ICAR, static for yield data. And third is UCI, crop recommendation data set for soil and environmental factor. We cleaned and normalized all the data, removed all the outliers, and filled missing values. For disease detection, we use conventional neural network, that is CNN. For yield prediction, we use random forest and XGBoost model. IoT sensor provide real data input for integration and fertilize control. Model were trained using 80 to 20 ratio, and performance was measured using matrices like accuracy, F1 score, R square, or MAE. The goal was ensure about accuracy and scalability. These are the result. Now let's talk about the outcomes. Our CNN model achieved 95% in detecting leaf disease. That's a huge boost for early disease management. Random forest and XGBoost give strong yield prediction with R square value exceeds 0.88, meaning they captured real yield pattern very well. And most importantly, when we integrated IoT and ML, farmer could save up to 30% of water and fertilize without affecting yield. So not only in the system accurate, it's only sustainable, it also sustainable and eco-friendly. These are the future direction. The future direction of the agriculture is intelligence and connected. Imagine AI powered system that automatically control irrigation based on soil moisture and weather forecast, or climate smart agriculture where ML help breed crop resistant to throughout or pest. AI will also play a key role in predictive supply chain, forecasting demand, and optimizing logistics. The next big step are building regional specific data set, developing lightweight AI model that run on the low cost devices. And next is what? Creating open data platforms so researcher and farmer can also collaborate globally. These are the challenges and the limitations. So there are still challenges. Many models face domain shift, meaning a model trained on one region doesn't perform well in another. Data scarcity and infrastructure issues in a rural area make implementation difficult. IoT devices are still costly and not widely available. And most AI models are crop specific, so they must be trained for a new region or crop. To overcome this, we need local data collection, affordable technique, and policy support to encourage farmers to adopt these innovations. These are the conclusion of my paper. To conclude, artificial intelligence and machine learning are redefining model agriculture with model like CNN, random forest, and XGBoost. We can detect disease early, predict yield accurately, and use resource wisely. Our research clearly shows how IoT integration can reduce water and fertilizer use, a crucial step towards sustainability farming. However, to make this revolution accessible to all the farmers, especially smallholders, we must focus on the data availability, model generalization, and affordability. With the right collaboration, AI-driven agriculture can ensure food security, sustainability, and resilience for the future. Thank you so much. These are the references. If you have any questions, so please let me.
Thank you so much, ma'am, for the presentation. We are open to questions now, if any.
Hello, Anuradha.
Yes, sir.
I'm asking one question.
Yes, sir.
How does AI-driven precision agriculture different from traditional farming method in terms of resource optimization and yield prediction?
So I think using AI or ML, we make a smart things. If we are talking about traditional method, so historical data, based on the historical data, we predict ki what type of crop and what type of means कौन सा हम लगा सकते हैं basically. Or in case of we are using AI ML, so we can use data set to train our model to predict what type of crop and we are predict.
Okay. Okay, thank you.
Okay, sir.
Thank you so much, ma'am.
Thank you, ma'am. Can I stop my slide?
Ma'am, sure.
Thank you, ma'am.
Okay, so now I would like to invite our fourth presenter for the day, presenting the paper titled Unraveling Crowd Dynamics, Wi-Fi Tracking in Public Environments, under the code number 207. I request Sir Akshay Jain to kindly take the virtual stage and begin the presentation. Okay, I think Sir is not there right now. So meanwhile, we'll be moving on to the next presentation for the day, presenting the paper titled Dual Direction Unified DC-DC Power Converter for Electric Mobility Applications under the code number 210. I request Sir Kalyan Shree to kindly take the virtual stage and begin the presentation. Is Sir present here right now? I think Sir is not present right now here. So
Hello, ma'am.
hello.
Can you please kindly wait a minute? I'm sharing my screen.
Okay, okay. What is the presentation code? Is it 210?
Yes, ma'am. It's 210. Paper ID 210.
Yes, ma'am. Yes, sure.
Hello, ma'am. Is it visible my screen? Hello, ma'am.
Ma'am, your screen
Ma'am.
is not visible, ma'am.
It's not. Is it not visible, ma'am?
No, ma'am, it's not visible.
Okay, ma'am. Just a second. Ma'am. There is a signal issue here. Can we present it a little bit later, ma'am?
Okay, ma'am. Okay, all right. Not an issue.
Okay, ma'am.
Okay, so meanwhile, we'll be moving to the next presentation of the day under the code number 211, under the paper titled Big Data Analytics for Large Scale Loan Application Management, a best of breed approach with open rule. I request Ma'am Jaya ma'am to kindly take the virtual stage and begin the presentation.
Thank you. 1 second. Microsoft entire screen. You're able to see my screen, right?
Yes, ma'am, your screen is visible.
Okay, thank you so much. Hello, everyone. Today we're talking about big data analytics for large scale loan application management, a best of breed approach with open rules. Here we are presenting 4 authors together. My name Jaya, I'm Jaya and Ram, and one of my other co-author Lakshmi Vanam also joined this call, and Durga Krishnamurthy. So this is a presentation on a scalable, cost-effective, and compliant framework for processing high-volume loan applications. So just to give a little background about this, when there was a COVID a couple of years back in the United States of America, there were a lot of small businesses that got impacted, and I work with Bank of America, and our company, not just our company, in fact, as a matter of fact, all the banks or the government supported with a paycheck protection program for all the small businesses whoever got impacted with the COVID of not able to run their businesses. The government allocated to have funds issued for all the small businesses that got impacted, which is called the PPP program, which is Paycheck Protection Program. And all of a sudden, we have to process 300,000 loan applications, and we have to allocate like $20 billion funding. Again, I'm not giving the exact realistic numbers because we do not want to share companies any sensitive data, but this is just a high ballpark number of how many loan applications should be processed all of a sudden within just a couple of months, like 1 to 2 months. And it's realistically not possible because of the number of loan applications that we get is in general is not compared with the amount of applications we got during the COVID time. And a lot of associates, employees from our company, at least just our Bank of America, we all have to volunteer, take extra time. We brought in so many resources. Majority of the people have been working day and night trying to change the code and to meet the needs to process these many applications and to allocate these many $1 billion of funds. And we have used Pega application workflow to process the loans. So this was an inspiration for this topic to talk about what are the other tools or frameworks that are available, not just Pega, like rules. We are talking about open rules framework, where it's a very light scale framework that can be used to process high. I mean, if at all we get into a situation, anyone, since this Pega is an expensive tool, we are proposing another tool that is available. And also not just that, in our company, like the ingestion, data ingestion, what we get are, again, definitely there are some lines of business where they use traditional approaches, but what we are trying to do is we're trying to combine the big data tools to process huge volumes of data. So the model of this particular paper, what we are presenting, is we are trying to utilize all the current available big data tools and the open source open rules framework to have a cost-effective, scalable, and compliant solutions at a very high scaled approach. So here, even handling peaks of 25,000 applications per second, definitely if we go with the traditional tools that are available, it might not be a viable option. So we would wanted to propose the big data tools that are available and how we can leverage from it, and how our model is making sure that we are having regulatory compliance. So open rules is Excel-based decision table. It's a lightweight framework where business users can update the rules very easily. We don't need like even people with not lots of coding knowledge if they are not available. I mean, we can just use this because it's very low coded. Like when you enter the data in an Excel with the decision rules, whatever you wanted to make, that will convert into a backend. The API will convert into Java code, and the decisions will be implemented on whatever data we ingest. And it outperforms the alternatives in user friendliness, and the amount of time it takes is less than 200 milliseconds. Here, the framework overview and big data architecture. I'll go with the diagrams in the upcoming slides, but just to mention, we have like structured data, unstructured data. I will give an example. Like once we have a structured data of credit scores and unstructured data like social media, transaction histories, we are aware that big data can capture any type of data, right? So in that, Hadoop, HDFS, Spark for processing, AWS S3 are some of the technologies that are chosen, and integrating with Kafka for a real-time batch processing. And predictive analytics and machine learning, here we're talking to using XGBoost isolation feature for fraud detection. Like there are high chances that there will be some errors. Like there are when we are doing this in the paycheck protection program, people do submit fake data, fake applications with fake evidences. So there will be, we also have to have proper tools to identify the fraud. And then the reinforcement learning for loan pricing or optimization, real-time processing, open rules integrating with Spark, Sharp for explainability, ML flow. We're talking about data encryption, and then fault tolerance, robust orchestration. So here, just as I mentioned about the open rules decision engine, we'll give like as an example, this is the credit score. And then this is the debt to income ratio, and then this is the status whether the loan application should be approved or rejected. So if the credit score is greater than 700, like and the debt to income ratio is less than 40%, go ahead. If it is between this range and debt to income is less than 50%, then you have to review. Like these are some just one sample decision engine, but there will be different types of tables that we can give via Excel to make the decisions. So now let's quickly look at the diagrams. This is a visualization diagram. Like, okay, let's assume we have to have $20 billion for different mortgage loans, auto loans, business loans as an example that we get. And how does a loan application workflow processes? Like when a person submits an application, we process the application data like through client API, and its data is ingested through the data pipeline, and different processing and analytics are applied here, like requesting for risk score and the rules. And the decision engine is applied here, and the score is evaluated with different models, and whether we have to allocate the funds or no, and if there is any fraud, anything is being detected, the alert will be sent out, and the application status, whether the application is being accepted or rejected, the loan application, and finally the reporting layer. So here, if you look here, like the data can be.
Ma'am, pardon me for interrupting you, ma'am, but we have got 1 minute to wrap up the presentation. Okay.
So the data we have, like structured and unstructured data, is being ingested, like 15,000 records per sample, and Kafka. This is Apache Spark for storage, and then real-time processing. AWS for storage, and then moving on. This is for fraud detection, machine learning models, and here comes the story what I was telling all about the open rules decision engine, and finally the loan applications, what are being approved versus not, and the real-time Tableau dashboards. So for the sample data, whatever we talked about, the processing time, like for data ingestion, ETL processing, machine learning prediction, and the open rules decision, fraud detection and fund allocation, and finally, just for a sample, 10,000 applications are processed during high peak hours with no delay, with less than 200 milliseconds. And like about like when we're talking about $20 billion of funding, like about $120 million, like if there is any false positives that are being captured, and then yeah, we're talking about the customer experience on the less number of time taken when we try to combine both big data and open rules decision engine. So finally, I would like to conclude that open rules integrated with big data tools deliver a scalable, cost-effective, and compliant solution for large-scale loan management. Ease of use, efficiency, and regulatory adherence makes it a superior and alternative. Again, this is not for huge companies, like not, I would not say like companies, big fintech companies like Bank of America and all, they would just go with this open source frameworks, but this is just alternatives that we are suggesting apart from Pega or rules. Thank you so much.
Thank you so much, ma'am, for the presentation. Now we're open to questions, if any. Okay.
I'm asking one question. How does open rule facility decision modeling in large scale loan application workflow, and what advantage does it offer over the traditional rule engines?
So Pega application costs, just for licensing, it costs around 1 to 2 million. But there will be a lot of smaller companies who might not be able to have, that much cost, pay that much expensive tools with huge cost, and even finding Pega resources with also is, I mean, definitely they are all with expensive, right? So I'm not saying that this open source tool will be used by larger companies like Bank of America or any other fintech companies, but this is just a proposal or a case study that we can embrace open source tools as well. And when we try to integrate it with big data tools, it can be cost effective solution, and of course it's scalable solution. Having said that, I'm not saying bigger fintech companies will go with that route, because they, for them, safety and I mean, is also important, right? So pretty much there are high chances that, of course, in our company, we are using Pega. We are not just going with any open source tools at this point, but this is just a proposal based on what we have, at least what I have experienced during COVID, of suddenly processing 300,000 loan applications at a very limited period of time, and we don't have the skills and expertise all of a sudden. So since this is low coding approach, we thought we want to present this case study.
And
Okay,
Jia,
thank you.
I have one question. So looks like you have studied between Pega and Open Rules, right? Did when you were doing comparative study, did you find that there are security features, what security features this Open Rules was lacking, which makes it difficult to implement for big tech? So like, can you walk us through some of the security features?
Open source tools are definitely something to be considered by larger companies, right? I'm not saying it's does not have security features, because it's being promoted. However, all I'm trying to tell is, for example, even we are not going ahead and at least in fintech companies, larger fintech companies, we don't go with all the bleeding technologies and just go ahead and embrace it like, hey, this is the current trend technology in the market and let's go ahead and work on it. Rather, we look at the market and we look at the tools that are there for a very longer time in a sustainable way, and Pega has been there for many, many years. So many new tools come into the market, right? So it does not say that the new tools does not have security features, but larger fintech companies might not embrace the bleeding technology. Instead, they go with the traditional, more safer approaches to meet, because we are in a very highly regulated industries. So for smaller scale companies, product size companies, yes, they would embrace these tools that are available, but it does not mean it does not have scalable features, I mean, or security features. It's just that at least bigger fintech companies take time to embrace such tools that are available in the market for a lesser price, lesser cost, and higher speed due to its regulation and to protect the customers.
Thank you.
All right. Thank you so much, ma'am, for your presentation. So now we'll be moving to the second presenter, Sir Vishal Sangani. Sir, are you ready right now?
Oh, yes, I am. Yeah, yeah. Thank you. And then
Yes.
sorry about previous
Not at
problem with my browser. So yeah, this is Vishal, and then I have my co-author Mahesh Kumar with me. Let me start presenting actually. So I think you guys can see my screen, right?
Yes, sir. Yes.
Okay, awesome, right? So this paper is like a let me just haven't started my. So this paper is about having different kind of anomalies. I mean, on your data actually, it can be any kind of data, right? So we have a traditional way of finding different kind of anomalies. It's like more of some kind of say viruses or ransomware or whatever you see, right? So you have a traditional way of finding that in any kind of anomalies from your data. So this paper is like more of talking about anomalies that can reside on your backup data, right? So when all the enterprises for the different compliances and then different data availability purposes, they take backup in regular different intervals and then regular other sources. However, generally those backed up data, right, are generally not scanned regularly to find out those anomalies. I mean, in recent days, like I mean, probably past 5 or maybe 10 years, there are different startups and enterprises coming up. They are actually giving this kind of facilities. But prior to that, there was nothing like that. So I mean, and then whatever so far, whatever exists, still that may not be enough for complete solution. So the intention of this paper is to provide to suggest a framework. That framework is based on machine learning models, like which combines both actually supervised and then the non-supervised, the unsupervised models. So this is kind of like hybrid machine learning based model framework, which helps different kind of customers finding anomalies in their backup data, and which primarily reside on the different kind of cloud environment. So when you say cloud, it can be like say Google Cloud, or it can be Amazon Cloud, or it can be Microsoft Cloud, or it can be like say IBM or Oracle Cloud. So this is about that. So this is the agenda where I'll start with what is the primary problem with the current existing legacy-based product, legacy-based anomaly detection solutions, and then along the way I'll also discuss about the proposal, then the architecture, and then the different data based on the experiment done based on the data collected. So as I mentioned earlier, right, the legacy-based model, right, those are kind of like very kind of legacy, which works on primarily some kind of signatures. So let's say signatures are generally, you calculate signatures of different kind of files based on their some unique ID. It can be like say a SHA-1, or it can be an MD5 of that file. And then you generate those data, maintain somewhere in some data, some file actually. And then whenever some new file, something comes up, those antivirus solutions generally get these unique identifier and then check against the existing database, and then see if that has some any kind of anomalies or not. But those kind of solutions are not that helpful. The reason is like there are some 0-day problem. Let's say for example, someone has, I mean, hackers are always like ahead of the other guy, so they may come up with some innovative idea, and then they can come up with some 0-day vulnerability or 0-day virus. And then in that kind of situation, right, this kind of like signature-based solution will definitely not help. So in that kind of scenario, right, the proposal is, I mean, we definitely have some kind of solutions available, but this is some kind of different proposal where instead of completely relying on those kind of signature-based solution, we use the existing, you use the available machine learning models. And then with that, you combine those machine learning models, like say a supervised and unsupervised machine learning model, deploy the solution on your cloud, and then actually look at those data which are coming into your different clouds, and then generate a different kind of like detection, and then the give the different administrator the way to react on them, and then eventually correct on them. Right. So the proposal is, as I mentioned earlier, it's like it's a hybrid machine learning based framework, which is primarily focusing on detecting those anomalies. And then that currently is like this. This is like very initial framework, which currently based on the file or files metadata primarily. Right? So when I say metadata, it's like more of a file size, file creation time, file modification time, And then on top of that, there are backup logs, as well as the backup logs contains actually the information about different kind of files, file size, as well as previously, I mean, what was the time taken for that? What is the storage required for that? Is there any data deduplication or compression actually done on that file? And then when those files were stored eventually in the different storage, right? What is the storage utilization for that? As well as the backup frequency, right? So those are the data inputs taken actually, and then those inputs are given to different the supervised and then unsupervised learning-based models. So primarily, for the supervised learning, right? Primarily random forest and then the support vector machines algorithm were used, and then for the unsupervised, it's like autoencoders as well as the k-means clustering were used. So these are the like primarily initially these 4 algorithms used to process all the generated data. So this is the very simplified architecture. I mean, probably I think it might not be completely visible. It's said in my paper. So this is the very simplified architecture. I just put having just 4 processing units here. But if you go in detail, it will be like very much detailed one for each and every stages, right? So this architecture, what it does is like it uses different cloud providers APIs. For example, right? Generally, when any backup is done right on the cloud, so most enterprises uses the cheapest storage, which is like primarily S3 storage. When it comes to Amazon, when it comes to Microsoft, it's Azure Blob. That way, Google has its Google Cloud Store, right? So that's you store that information within those different cloud stores. So from that cloud store, that's where your this framework or this application starts. So basically, it starts collecting data out of it. Like so, when any data is dumped on this data store, you use different cloud provider APIs, collect as much metadata information as much as you can actually. So that will be your primary ingestion point for your engine. So once you have the data collection done, then because the data is like very rich, right? I mean, very rich set of data as well as it has the large amount of data because it includes the logs as well. So then you do some kind of pre-processing. So that is what the second stage is, like pre-processing. You do some normalization based on the size of the files. I mean, the files, so for example, size of the logs, say maybe KB to MB conversion, MB to GB conversion. So that way, that can be easier for the models to work on that conversion. Then you do some kind of like feature extractions, for example, rate at which those files being backed up, what was the previous backup time, what is the size of the file. So those kind of information you, as part of pre-processing pipeline, you extract all the information, and this information will eventually given to your anomaly detection engine. So this engine is your core part, which actually contains the ML-based engines, which has like there are 2 engines basically, and then one is like for the supervised base, second one is the unsupervised base, and then those 2 engines generates data, and then both are combined, which is given to the hybrid engine, and that hybrid engine eventually gives based on the past data collected. It gives the information about the collected data with respect to say any file have any anomalies or not. So this is how it is, and then eventually there is a alert and virtualization layer, which is like more of the graphical presentation of your detection, right? And then within that layer, you have a facility to give a real-time notification or some kind of dashboards. Like when it comes to real-time notification, I mean that way that notification can be shared over email to the subscribed users, and then eventually this dashboard and this complete application can be integrated with different cloud providers. So this is not any cloud provider specific framework, which this framework is kind of a framework which can be used across any cloud provider. So this is based on the microservice architecture, where different this 3 basically part of this architecture, these 3 boxes kind of defining 3 different microservices. You combine these 3 microservices, and then you can create probably a Docker image and then deploy in different cloud platforms, and that can start pulling the data, and then eventually it will give you the result about the anomaly, whether it detects anything from the cloud data or not.
Pardon me for interrupting you, sir. You have 1 more minute to wrap up the presentation, sir.
Okay, yeah, sure, yeah, no, yeah, thank you, yeah. So yeah, then I'll go on a little bit speed. So these are the key metrics actually. So it does some precision, recall, F1 score, OCROC, and then the I'll just go over the comparison models and then the eval performance comparison. So that will give you a better idea, right? So these are some model comparison I did for the supervised. I mean, for the random forest SVM and then k-means and auto encoder. Like these are some of the advantages what each and every model can do, and then some limitation at this point of time, and then what each and every model accepts actually. Let's say, for example, random forest, it accepts the some corruption pattern, SVM, which accepts the unauthorized access detection. Then we have the k-means, which is like primarily for detecting a storage utilization. Like say, maybe you have a every day you are seeing the storage utilization for this backup is maybe 5 gig, but eventually you are seeing let's say 550 gig. So what is the problem for that? So this kind of anomaly it can actually point out. And then the fourth one is autoencoder, like which detects the ransomware kind of like say it has the ransomware induced backup changes. If there is any other backup related changes are done, that is what it detects. And these are the different kind of like performance comparison using those models, how it behaves, and then eventually what are that accuracy rate. And then when you combine all of these like core models, the hybrid model is the one which actually gives you the better accuracy over any one or the other one. And then also it has the less false positive and then less false negative with respect to this one. Okay, so as I mentioned, like so finally, like final point where different challenges for this model is like as I mentioned, it is just a framework, and then this is not yet an enterprise-ready solution. It's just a first step, going to the larger way. However, the current challenges are like a scalability, right? So currently, because of the not enough amount of real-time data available, so it has a problem of scalability. And then other thing is like data scarcity also. Like again, the label data are not available for the supervised models. And then the model has to be retained every time, right? So I mean, this security landscape changes every day. So you need to frequently change your model, you need to retrain that. So that has some cost. And then false positives, like I mean, if you do not do those model retraining, then you might end up in more false positive or false negative. That is again a problem. Those are the okay. Sorry. And then the future research, right? So I mean, currently does the detection, but the future we can
I'm
add the.
extremely sorry. Could you wrap up the
Sorry, yeah.
presentation pretty fast, sir? Sure.
Okay. No, I think yeah. Thank you very much. If you guys have any questions, please let me know.
Thank you so much, sir, for your presentation. We are open to questions now. If there's any question.
Yes, Vishal, one question.
Yeah, sure.
What is the specific characteristics of backup data distinguish your anomaly detection approach from those designed to real-time network or application data?
Right. So, I mean, real-time network or application, right? Those are more of the data which is in transit that actually captures the data which is in the network or transit, right? And then does some packet inspection mainly, and then does the analysis on that. But this one is like more of a data in rest, which is residing on some storage, and then you use the metadata, not the actual data. I mean, actual data, you might have problem accessing actual data. The reason is there may be some privacy or problem. So you're not accessing actual data, you're just accessing the metadata for that data. So that is the differentiator where you do not need to actually touch the actual data with using this application. However, this is, as I mentioned, it's like an initial stage. So this cannot be at this point of time compared with the enterprise ready applications because it will not give you that high amount of like a detection and anomaly detection for this by this framework at this time.
Okay.
Thank you so much, sir.
Yeah, thank you very much then. Yeah.
Okay, so now we'll be moving on to the fifth presentation under the code number 210. So, okay, ma'am is present here. So you may begin with the presentation, ma'am.
Okay, ma'am. Ma'am, is my screen view?
Yes, ma'am, it is visible. Yes, ma'am.
Okay, ma'am. Here I'm going to present about dual direction unified DC to DC power converter for electric mobility application. And
Ma'am, are you speaking because your voice is not audible, ma'am?
ma'am, my screen is not moving, ma'am. Is this
What you can do is, ma'am, you can refresh your screen and again just present it.
okay,
There
ma'am?
might
I
be
will
some technical glitch here, sure.
Ma'am, is it changing now?
Yes, ma'am.
Okay. Uh, in our project, the introduction, the development of efficient and compact charging system is a vital for mass adaptation for electric vehicle. Bidirectional onboard chargers offer a promising solution by integrating charging and propulsion function. This bidirectional onboard chargers focusing on their architectures, operation, and benefits. By exploring the latest advancement and challenges, this study aims to contribute the development of more efficient, cost-effective, and sustainable EV charging solution. So the objectives of the paper is to review and analyze the current state of bidirectional onboard chargers for electric vehicles and to identify the advantages and limitations of integrated onboard chargers and to explore the potential of bidirectional converters in enhancing energy efficiency and driving range and to advance knowledge on bidirectional converter to technology to educate consumers on benefits and limitations of bidirectional onboard chargers. So here are the references we have taken. And the existing system is the unidirectional chargers, which is a traditional charging method using separate charging and propulsion systems. And it is using AC to DC converters, which converts AC grid power to DC for charging. And in existing systems, we are using pulse width modulations, which controls converter switching for efficient charging, and integrated charger inverter systems, combine charging and propulsion function. And we are here proposing a solution for this bidirectional charging, which is integrated charging and proportional system, enabling V2G and V2H capabilities. And it also has fast charging, high power charging for rapid EV charging, and we are using DC to DC bidirectional converters, which enables bidirectional power flows between battery and grid. And we are also using fuzzy logic controls for adaptive control for varying charging conditions. And this is our block diagram, which is uh, representing how the process and the main components we are using in this project is battery, which provides power to the systems, and the parameters such as state of charge and voltage are monitored to ensure system stability. And current measurement measures the current flowing from the battery to the motor it provides feedback to ensure safe operation and prevents overcurrent conditions. And switches, we are using some switches and electronic switches like IGBTs, MOSFETs, or relays to control the flow of power to the motor. And we are using DC motor here. It's the core load in the system which converts electrical energy into mechanical energy. It drives a mechanical system or load. And sinusoidal pulse width modulations or PWM generations. It generates switching signals to control the motor speed and torque, and it modulates the duty cycle based on the reference signals or commands. And we are using measurement displays, which monitors and displays various system parameters such as battery, SOC, voltage, and current. And we are also using load and feedback system. A feedback loop provides motor parameters like speed, torque, or current to the controller for closed loop controller. And we are using gate drives, which interface between the PMW generator and switches, and it amplify and shape signals to operate the power switches correctly. And this is our results and the state of charge where uh, the battery while the battery stops in while braking, the charge decreases and then increases. The concept is regenerative braking. While regenerative braking, um, while applying brake, the sudden kinetic energy is converted into electrical energy. Where while we are moving the car, the state of charges will decreases. But while applying, uh, due to electromotive induction, the kinetic energy is converted to electric energy, which is after applying the brake, the charges will increases. This is shown in this graph, and these are the references we are taken. That's all, ma'am. Thank you.
Thank you so much, ma'am, for your presentation. We are open to questions now, if any. Okay, so we don't think so there's any questions, ma'am. So you may stop presenting the screen, ma'am.
Okay, ma'am. Thank you.
Okay. So now all the presentation is done, and now I would like to share the certificate of the appreciation for a session chair, Dr. Amit Sharma, and now I'll be presenting the certificate for sir. Just wait a second. Thank you so much, sir, for your valuable time and for charging this session. And I'll be sending you this certificate shortly, sir.
Thank you.
Thank you so much, sir. And yes. Okay, so with this, we conclude today's paper presentation session at NICE TEAS 2025. So now we sincerely thank all our presenters for their valuable contributions and our audiences for their active participation as well. And a special thank to our session chair for guiding the discussion with clarity and depth. And thank you so much everyone for participating. So now I would request all the participants present here to kindly switch on the cameras as you take a virtual photograph to capture this moment. So I would request everyone to please turn on the camera for a few seconds. So just we could take the photo. It would be really great if everyone would switch on the camera. Okay, so not an issue. I think they won't be able to open the camera. So now I'll be taking the photo. 3, 2, 1. Wait a second. Okay, thank you so much, everyone. Okay, ma'am came just now. So we'll be taking one more photo. Yes, ma'am, you may turn on your camera. Gobika, ma'am. Okay, let's take again. 3, 2, 1. Thank you so
Thank
much.
you.
Thank you so much, everyone.
Thank you. Have a good day, guys.